Welcome to Introduction to Electrical Engineering. And in this first lecture, you'll learn what electrical engineering really is, what the different fields there are within the electrical engineering, and what electrical engineers do. So when we talk about electrical engineers, we know that it deals with electricity. In fact, it's the study of electricity and how we can use electricity for a specific purpose in our daily lives. For example, the electrical train that you take to go to work uses electricity to generate motion. The street light uses electricity to produce light. The washing machine uses electricity to wash your clothes. And the speaker, the light, and the internet, or any device that uses electricity, is a product of electrical engineering. There are a number of basic electrical concepts that are fundamental to the job of electrical engineers. Electrical engineers must know what electricity is, how it is created, how it's transmitted and controlled, how it's changed into a form of energy that meets the human needs and wants, and most importantly, how to deal with electricity in a safe manner. To give you an idea how electrical engineering fields of study are broken down, here is a list of different engineering fields in electrical engineering. There's power and energy system engineers, signal processing engineers, control systems engineers, microelectronic engineers, telecommunication engineers, and photonics. Usually you will get to choose one of these 6 fields to specialize in your final year of study in college. However, each of these fields do require a bachelor's degree, and you must take courses in electricity, electronics, chemistry, biology, physics, and higher level math and statistics. Now I'm going to break down each of these 6 career fields. First of all, power engineers, also sometimes called energy system engineers, deal with power generation, transmission, and distribution of electrical energy. Their main focus is how you generate and deliver electrical energy to your clients at the most cost-effective way. For example, the policies of a power systems engineer would have to figure out would be how to avoid damage from a natural disaster like a thunderstorm or earthquake, or when the system is already damaged, how can they recover in the shortest period of time? If you choose to specialize in signal processing, you will work with signals such as sound, image, video, music, and brain signals. The purpose of signal processing is to extract the most important information out of the signal using mathematical algorithms. A good example of signal processing is a lie detector that the police used when it's first captured a person's speech into an electronic device like a computer. Then it extracts the relevant features to determine the possibility of lying. Also, devices like eye scanners and video cameras are a product of signal processing engineers. The focus of the control system engineer is to design a system that provides a controlled, stable output that is time efficient. For example, if you compare older elevators with new ones, you might find that new elevators are more quiet and more supple, but sometimes they can be a bit too slow. And that is where the focus of the control system engineer comes into play, to be able to develop and improve a system that is faster but stable at the same time. The control system that takes into account external disturbances such as rain, wind, or even human forces on the system that will adjust itself to provide a stable output. For example, the temperature control on an air conditioning unit will take into account the ambient temperature and adjust itself accordingly. Another example is a robotic vacuum cleaner, which will scan the surroundings and avoid obstacles. Microelectronics involves the study of electronics at the microscopic level. So instead of dealing with electricity, they work with electrons and photons, which is how our computers, laptops, and phones are getting smaller and faster. A lot of new technologies, such as the solid-state drive, is also a product of microelectronic engineering. And you might have also heard of quantum computing, and that's what microelectronic engineers are working on right now. Telecommunications engineers deal with data transmission and reception. It is a discipline founded around the exchange of information across channels via wired or wireless means. It brings together all the elements of electrical engineering, including computer engineering and systems engineering, to create and improve telecommunication systems. Just imagine the billions of people that are sending and receiving phone calls and videos and images across the world every minute. How this data is sent and received so reliably in such a short period of time is what telecommunication is all about. Lastly, we have photonics engineers. Photonics engineers work in the design, production, and use of laser and fiber optics technology. The job title comes from the word photon, which is a unit of light. Photonics is the science of using light to generate energy, detect information, or transmit information. The most common example of photonics engineering is the use and design of solar power panels, which some households have. How to efficiently convert the solar power into electricity that we can use is what photonics engineers work on. Also, things like fiber optics, which use light to transmit data, are a result of photonic engineering. So that brings us to the next question. What do electrical engineers do in each of these fields? The engineers can be further assigned to different roles. For example, there are design engineers who do the initial design, project engineers to manage a particular project, systems engineers who maintain and monitor all existing systems, and so on. In order for a particular project to be accomplished, all of these engineers have to focus on their role, finish their tasks, and pass on the results to other engineers. So in conclusion, there are a lot of variations of electrical engineering, but one common theme is that it is crucial to acquire the knowledge necessary for a particular job, apply it, and most importantly, communicate with each other. So now hopefully you have a better understanding of what electrical engineering is and whether you would like to learn more about it. If you have any questions, please ask your instructor, and have a great day.